All right, this recording is about equilibrium and some of the uses for KSP. So we're going to look at the different things that you can solve, the different types of problems that you can solve using KSP. So one of the applications is looking at Q versus K. And remember, Q is the reaction quotient, which is found by taking the initial concentrations and applying it to a K-like expression and comparing it then with the K, which is at equilibrium. So remember that Q is at the beginning before the reaction has occurred, and K is at equilibrium. So when you compare Q and K, you're able to see which way that the reaction goes in order to establish equilibrium. If Q is bigger than K, then the reaction is said that it will precipitate, meaning you have more dissolved ions, and they are going to favor the side that is the reactants. So it is moving in a backward state. So if we look at a reaction, sorry, my pen is not cooperating. If we look at a reaction, say for instance PbSO4, and we have Pb ions and SO4 ions, and if we say that it's precipitating, we can identify that the solid is forming, so we are moving toward the reactants. All right. Now, if we say that Q and K are equal, then it is completely saturated and there's nothing going on. You have as much ions being formed as solids being formed, so it is at equilibrium essentially. And if Q is less than K, then we are going to say that the solid is dissolving. So in the case of looking at the reaction, the solid is dissolving, so we are favoring the products. So you could go back in here and you could say that the products are favored for the last case, and the reactants are favored in the first case. So remember, think about what Q means and what K is telling us, and you'll be able to decide which side of the reaction is favored, just like we did in past instances we're looking at Q and K. This sample problem gives us, will a precipitate form when 0.1 liter of 8.0 times 10 to the negative third molarity of PbNO3 in parentheses 2 is added to, sorry there's a typo, is added to a 0.4 liter solution of 5.0 times 10 to the negative third molarity Na2SO4. What they're asking you to realize is this: because this is nitrate, nitrate doesn't form, and because this has a group 1, that doesn't form. So you're really dealing with Pb in a +2 state and SO4 in a -2 state. So you're actually looking to decide if Pb, if you have PbSO4, this pen is really giving me problems. I'm going to have to use my finger. PbSO4 will form from the Pb ions and the SO4 ions. So what we're going to need to do is come up with the concentrations and plug it into a K expression and compare with the K, the actual K for PbSO4. I looked it up, and Ksp for PbSO4 is 6.3 times 10 to the -7th. So we're going to compare what we can find with that Ksp, and it is in really terrible shape. All right, we have a volume and a molarity of the PbNO3, and we have a volume and a molarity of the Na2SO4. We're going to need to find the number of moles and then calculate the new molarities. Plug that into our Q expression. So here we go. We have 0.1 liter. So we know that we have some number of moles equal to 8.0 times 10 to the negative third. And when you do the math, you get the number of moles is going to be 8.0 times 10 to the negative fourth. And this is for our Pb ions. We're going to have to keep track because there's going to be a lot of numbers on this screen. So the next problem is we're going to figure out the number of moles for our 0.4 liters, and our 5 times 10 to the negative third. And so when we do that, the number of moles is going to be 2.0 times 10 to the negative third. And that is for our SO4. Now these are both moles, so we're going to have to divide them by, I'm going to change colors so we can see it a little bit. We're going to divide by the new volume, and the new volume is 0.5 liters. So that will get me a PB concentration of 1.6 times 10 to the negative third. And if I divide this by the same volume, that will get me a concentration of 4.0 times 10 to the negative third. Now this is my PB and this is my SO4. So to find my Q, I take my products divided by my reactants, and I don't have any reactants that I'm going to divide by. So I take my 1.6 times 10 to the negative third times my 4.0 times 10 to the negative third, and I will get a value of 6.4 times 10 to the negative sixth. We are going to compare our Q and our K, and you can see that Q, in this case, is bigger than K. Look at the exponents, negative 6 versus negative 7. Q is bigger than K, so we know that our PbSO4 will precipitate. So we are going to be favoring the reactant side. Okay, sorry for the mess. If you follow along, great. That's an example of how you would use the Q versus K with respect to KSP.